Hello and welcome to today's lesson on types of variables and association of bivariate or two-variable data. Our objective for today is by the end of this lesson, we'll be able to identify explanatory and response variables and describe the association of the two variables in a graph. So when we look at bivariate data variables, we want to make sure that we're using the proper terminology for statistics purposes. So our first variable is the explanatory variable. Okay, it's the independent variable, or what is being manipulated in a given experiment, a given study. Okay, and we plot this data on the x-axis graphically to make sure it's visually represented the proper way. And then we have our response variable, okay, which is the dependent variable, okay, which is plotted on the y-axis. And our whole goal is we're going to use the explanatory to give us a prediction for the response when we start creating least squares regression lines. So we're going to use regression to make an estimation, but right now we're looking at the graphs and doing explanations for them overall. So now, if we look at these two data values, okay, this is a random sample of 10 students, semester 1, and they have their final average and their homework average. Okay, now I want you to take a look at the organization of these two variables and see if it is organized properly. Okay, if you're watching at home, pause here real quick, make a decision, and then come right back. Okay, now when we look at these two variables, what we want to do is we want to say a sentence in our head. Should the final average respond to the homework average, or should the homework average respond to the final average? Okay, one of those two sentences should have made just a little bit more sense overall. And what we're looking at, and I put these in the wrong order on purpose, okay, as a student's homework average is their explanatory variable. It's something that we can manipulate, and what we want to see is what is the response on their overall final average. Okay, so if we look at some of these categories, we want to make sure that we're classifying them correctly, because then the graphs will be organized in the right order, and we really want to just present things properly overall. So when we're looking at some of these situations, first situation, the current value of a car and the age of a car. Okay, what's the explanatory? What's the response? Okay, the current value responds to the explanatory value of age. Okay, so as a car ages, okay, it loses value, and there ends up being some point where when a car becomes a collector, okay, that would change, okay, but the value of the car is in response to the age of the car. Okay, if we have heights of mothers and heights of their teenage daughters, okay, so we're looking at moms versus daughters with respect to height. Okay, the daughter's height would respond to the explanatory variable of the mother's height. Your amount of sleep and your energy level the next day. Okay, in most cases, your energy level is going to respond to the amount of sleep for that given situation. And then our last one here at the bottom, the money you earn and the hours you work at a part-time job. Okay, the money earned is in response to the part-time job, which is the explanatory variable. Okay, now, once we've identified and we put our graph together, okay, labeling our axes, so we have, in this case, these are our homework averages across the x-axis, the final grade average across the y-axis, and we have these values. Now, this scatter plot was created on Excel, okay, but the tool that you're going to have most often is your graphing calculator. Okay, so we want to show briefly how we can construct a scatter plot using the graphing calculator. Okay, first thing that we want to do is go into our stat function and edit. Okay, if you have anything in your list, you can go up and clear, enter to get that knocked out. Okay, but we're going to put our x variable, our explanatory, in list 1. Okay, so we've got 69, 90, 80, 91, 98, 97, 80, 70, 90, and 56. Okay, then we've got our y variable for their final average, 75, 89, 80, 77, 98, 81, 88, 78, 79, and 66. Okay, so we have our data values in. If we want to do a scatter plot, we go second y equals, gets us into our stat plot function. Okay, you want to select one of them. It doesn't matter which one you select, but we usually just select the first. You want to turn the plot on, and if you notice, the very first option here in type is the scatter plot. Okay, we've got list 1, list 2 for our x and y variables, and the color of blue. Now, to get to your graph as quick as possible, we will want to do a zoom, and you can zoom 9, which is zooming to your statistical values. So we can see a very similar graph to what we had from Excel. Okay, a little bit of a different scale on it. Okay, but we can see that very similar relationship between the two variables, homework average and final average. Okay, so now when we're looking at graphs, we have to be able to describe certain things. When we're looking at our data, comparing our explanatory and our response, first thing that we want to talk about is our association. Is it a positive association? The explanatory is increasing, the response is increasing. Okay, when we look at this, we can really be thinking about the slope of our least squares regression line. We can see in both of these examples that line is put in, and we'll talk about that in lessons to come. A negative association, as the explanatory is increasing, the response decreases. Okay, that gives us the negative slope or negative association of those values. Okay, if we go back and look at our situation where we're looking at homework versus final grades, we can see a positive association there. Okay, so as the semester homework is increasing in percentage over the course of the term, the students' final percentage is increasing. Not in every case, but in the majority of cases for the pattern. Okay, now the next thing we want to look at is strength, because even though we have association, it's a positive association, it's a negative association between two variables. We also want to look at the data and talk about strength. So we can see this top are all positive associations, but they're very different. Okay, this first one we would consider a weak positive association. This middle one is more in the moderate positive association. Okay, then we get to strong positive association, and then we finish up with perfect positive association. Okay, and then the same thing at the bottom. Here are our negative associations. Okay, this first graph, it's almost hard to see any downhill trend. Okay, there definitely is a little bit of one through here. Okay, but these bottom values really kind of take away from that. So if you're looking for association, one thing you can do to help yourself is eliminate some of those outer values and then look at the majority of the graph. That will help you with association if it's not a strong association like we see in some of the other graphs here today. Okay, so that's what we're looking at for today. Okay, very small. Looking at explanatory and response variables, making sure that we're organizing our graphs quickly, and then also talking about association and strength of the values. So we have our Schoology quizzes for homework, and in our in-class packet, we've got our page 1 set of problems where you're working on a couple graphs. Putting in the data plots, and then you can talk about their association. Thank you, and have a good day.